Hello, good morning all of you. So today is the fifth class on polynomial, and in our last classes we have seen the how to find the value of a polynomial, and also we have seen what is the zeros of the polynomial. In today's class, we will study relation between zeros and coefficient of the polynomial, and we will solve some questions on this concept so that our concept become more clear. So here, so first, already in the first class, I have explained what is the coefficient and what is the variable. And in the last class also I explained the zeros and variable of a polynomial. But still in this class, I will remind all the concept that is required for today class. So let's, if I have a polynomial px is equal to x square 2x plus 3. Yeah, in the general form, we can write this is as a x square plus bx plus c. So here, as you know, this is called the degree, and the term, any number by which we multiply the variable is known as a coefficient. And also we know that the value of polynomial is if if we are taking x is equal to alpha, and if we are getting p of alpha is equal to 0, then we called alpha is the zeros of polynomial px. So already we have studied this part. So today we will try to relate. We will try to find relation between zeros and coefficient of polynomial. So here we have polynomial a, b, and c is a constant, and a and b are the coefficient of polynomial. So in more general form, here we can write p of x is equal to a x plus bx plus c. So in this way we can write our polynomial where where a is not equal to 0. So in this way you can write. Now what will we do? We will try to find the zeros of polynomial figure. So let's, we have the degree 2, like if we have degree 2, we have 2 degree, it means we have a 2 zeros. It means 2 zeros. So zeros and degree will be equal. So means if we have 2 degrees, then we have 2 zeros. If the degree of polynomial is 3, then we have 3 zeros. So here now we can assume now zeros is, so let's assume alpha and beta are zeros. If alpha and beta are zeros, it means it means x minus alpha and x minus beta are factor of px. Means if we have the polynomial and alpha and beta are zeros, it means we have x minus alpha and x minus beta are factor of polynomial px. So if x minus alpha and x minus beta are the factor of polynomial px, then we can write polynomial px is equal to k times of x minus alpha into x minus beta. So like this way we can write our polynomial px. So what will we do now? So here, so this is our LHS part and this is our RHS part. So we will solve this relation. Then here we have yeah, k. So once we will simplify this, then we have into x minus beta into minus alpha x minus beta. So once we will simplify this, then here we have k x square minus xb minus alpha x plus alpha into b. Then once we will simplify this, then here we have k times x square. So here we can take minus x as a common. Then we have alpha plus beta plus alpha into beta. Correct? So this way you can write. And we have polynomial px is equal to ax square plus bx plus c, and this is equal to k times ax square minus x into alpha plus beta plus alpha into beta. So this is our relation here. So now what will we do? We try to compare is term by term. So what we'll do? We will try to compare. Yeah, one step you can do more simplification. This is as k x square minus x into k times alpha plus beta plus k alpha and beta. Sorry, this is not it. So here, if you will compare coefficient with equivalent degree, so here if you have two, then you have to compare with this one, and if and this coefficient you have to compare with this coefficient, and you have to compare C with this coefficient. So so after comparison we have A is equal to K. If I am wrong, please point out. And then we have B is equal to minus K into alpha plus beta. And C is equal to k times alpha into beta. So this is our relation. So now what we'll do? We will eliminate k. So this is the first equation, and this is second equation, and this is the third equation. So once we will eliminate, so take one by one. So from equation 1 and 2, here we have from 1 and 2 we can write b is equal to minus a and alpha plus beta. Correct? Then here we have alpha plus beta is equal to minus b divided by a. So this is the first relation between the zeros and coefficient of the polynomial. Now, so this is the first relation. So here I will write C as a first. Now, second relation from equation 1 and 3. So from 1 and 3 we have like C is equal to K times alpha into beta. Correct? And here we can write C is equal to, so here we have K is equal to A. So here we can write K into alpha plus beta. So now we can write alpha into beta is equal to C divided by A. So now we have the second relation. So here we just saw how to find the relation between zeros and coefficient of a quadratic polynomial. So here we have alpha plus beta is equal to minus b divided by a, and alpha, sorry, alpha into beta. So here I have alpha into beta is equal to c divided by a. So this is our relation. Correct? So here you can write now like sum of zeros is equal to minus coefficient of x divided by coefficient of x square, and product of zeros is equal to constant term divided by coefficient of x square. So I hope up to this point it's clear to all of you. Yeah, in more general term you can write sum of zeros equal to minus coefficient of x divided by coefficient of coefficient of x square. And the second relation we have, so this is the first. And the second relation we have product of zeros is equal to constant term, constant terms divided by coefficient of x square. So this is the second relation. So I hope up to this point is clear to all of you. And if you have any doubt, please ask your questions. I will solve your doubt first, then I will move to the next part. So if you don't have any doubt, so what I will do now? So I will solve one question today, and in the next class we will solve more question to practice it so that our concept become more clear and we do not require anything to memorize. So what I am suggesting once again to all of you, please don't memorize anything in mathematics. If you are memorizing in mathematics, so that is not going to help you anyway in exam anyway. So whatever you know, just try to know by tactics, try to know by understanding. Please don't memorize anything. And if you are feeling any difficulty in any concept, please ask in the class. And also you can post your doubt in question answer forum. And we will try to make you sure that you don't have any difficulty to understand any concept. So today what I will do now, just I will take one question. So here, so this is the first question, but in the next class we are going to solve only questions on this concept, and so that our concept become more clear whatever we have studied till now. So the first question is find the zeros of the polynomial and verify the relation between its zeros and coefficient. It means we have the polynomial px, and px is equal to 2x squared 5x minus 12. So what we have to do, we have to find the zeros and we have to validate the relation between zeros and coefficient of the polynomial. So here we have coefficient 2, 5 and minus 12. So first here we will write a is equal to 2 and b is equal to 5 and c is equal to minus 12. Now what we will do? So this is the first step. In the second step, we will find the zeros. So as we know, we have to find the value of x in such way, value of the polynomial px become equal to 0. So this is the way we have to put the condition to find the zeros. So here once we will write 2x square plus 5x minus 12 is equal to 0. So once we will factorize this. So here we can write this as x square plus 8x minus 3x minus 12. So at this point, if you don't do the factorization, so again we will be studying this chapter in the quadratic equation. There we will study how to factorize the quadratic equation in more details. So here basically we have to break 5 in such a way that So like this P and Q. So this like P is the Q. Sorry, Q. We have to break in such a way that P into Q is become A into C, and P plus Q become equal to B. So in this way we have to break. So like here, like I have 8 and 3. If we will add 8 and 3, then we have 5. And if we will multiply 8 and minus 3, then we have 24. So that will be equal to 2 into minus 12. So now what we'll do, we will proceed to the next step. So what we'll do, we will take the 2x as a common. Then here we have x plus 4. And from this two term, we can take minus 3 as a common. Then we have x plus 4 is equal to 0. So now what we'll do, we will take x plus 4 as a common. Then we have x plus 4, and this is equal to 2x minus 3. This is equal to 0. Then here we have x plus 4 is equal to 0. So here we have x is equal to minus 4, and 2x minus 3 is equal to 0. So here we have x is equal to minus 3 divided by 2. So here we have, two value. So here we can say alpha is equal to minus 4 and beta is equal to minus 3 divided by 2. So I hope up to this point is clear to all of you. So I feel like we are running out of the times. So, but still I will try to complete these questions. So as we know, like sum of the zeros is equal to minus b by k. So here we have LHS as equal to sum of zeros, means alpha plus beta is equal to. So here we have minus 4 minus 3 divided by 2. So once we will solve this, then we have equal to like, sorry, this is minus 4 and plus this is plus 3. So once we will solve this one, then we have minus 8 divided by 2. And similar way, RHS part we have is equal to minus b divided by a. So b is equal to, we have b is equal to, sorry, charge not, this is the 5. Sorry, this is equal to minus 5 divided by 2. We have b is equal to minus 5. So here that will be the minus 5 and a is equal to 2. So in this way, we can validate our LHS is equal to RHS. So here we can validate LHS is equal to RHS. So I hope up to this point is clear to all of you. And one more relation we have, that is alpha and beta is equal to C divided by A. So again we have alpha into beta is equal to, so LHS part we have minus 4 divided by minus 3, 2. So this become equal to minus 6 plus 6. And here we have C is equal to 12 So 12 divided by 2, that is equal to 6. So again here we have LHS is equal to RHS and RHS. So I hope this point is clear to all of you. And if you have any doubt, please ask. So okay, I can understand like we are running out of times. So it may be like it is too fast. But once we will meet in the next class, we will solve more questions on this, and we will try to understand more in more details. So don't worry. But I hope up to this point, all concept is what is you. So thank you. Please, when you are finding time at home, please try to solve some more questions. So thank you all of you. Have a nice day. Thank you all of you.